In problem 3, we have a matched sample. The people that are in the before sample are also in the after sample. So this problem simplifies the analysis quite a bit. It essentially, once you compute the differences in the final column of the table, you have a Chapter 9 problem. We want to know if an advertising campaign had any difference on sales. The phrase that is highlighted in blue is the alternative hypothesis. The average difference is not equal to 0. Thus, the null hypothesis is the average difference is equal to 0. So this is a two-tailed test. Now, when you copy this data into Excel, if you copy just the table itself, there might be a problem when you paste it into Excel. So what I like to do is I like to grab a period or a letter from above the table and then copy the data into Excel. I've already pasted the table into Excel. Now we just need to calculate the individual differences. And we always take the after minus the before. A cool thing about Excel is that if you put your cursor in the bottom right-hand corner of a cell and double click, you can get all the other differences calculated really quickly. Next, we want to calculate the average of the differences. We want to calculate the sample variance of the differences. And then the sample size is 10. Now, a cool thing about matched samples is, unlike an unmatched sample or unmatched samples, you have to use that monstrous degrees of freedom calculation to calculate the degrees of freedom. Here, because we've converted two variables into one variable, our degrees of freedom are just 9. In the difference column, I've copied all of the differences from the spreadsheet into this table. Next, I need to copy the means to 2 decimal places into Cengage Now. And then I'm going to enter the number of degrees of freedom here, because remember we computed the variance of the sample. We don't have the population variance. So this is a sigma unknown problem. So I'm going to enter 9 for the degrees of freedom here. Next, I need to get the standard error and the test statistic to 4 decimal places. The variance of the sample mean is less than the variance of the variable because we take the variance of the variable and divide it by the sample size. The standard deviation of the sample mean is the square root of the variance of the sample mean. This value is also known as the standard error of the mean difference. And I'm going to copy that into Cengage Now using 4 decimal places. The test statistic is the point estimate of the difference between the population mean and its hypothesized value, and the standard error. I'm going to copy that to 4 decimal places into Cengage Now. Since the significance level is 5% and this is a two-tailed test, we have 2 critical values. Since we have 2 critical values, we've got to divide the alpha by 2. The degrees of freedom are 9. So we're going to find the critical value in row 9 and column 0.025 of the t-table, which is 2.262. To conclude in part F, we have to compare the test statistic to the critical values. If the test statistic is in between plus or minus 2.262, then we have evidence in support of the null hypothesis. That is not the case here. The test statistic is greater than positive 2.262. Thus, we have evidence supporting the alternative hypothesis. So we reject the null hypothesis at 5% significance. Now, because the null hypothesis is rejected, what are we saying? Well, the advertising campaign had a difference on sales. And since the test statistic is greater than the critical value, we can say the advertising campaign had a positive difference on sales numbers. Now we're going to check our work. It looks like we got all correct answers.